Hey there, I'm Ben. I'm a member of the DevRel team at the Arbitrum Foundation, and I'm here today with my friend Justina to talk about ways in which Lava Network and Arbitrum can work together to really accelerate and empower developers building on Arbitrum. And I'm so excited, first of all, to hear more about this. But before we even get going on examining how this can work together, we need to understand what Lava is. So, Justina, what is Lava?
Hello, Ben. It's really great to be with you today and also talk about infrastructure developer tooling. And yeah, I'm super excited to tell you all about what Lava is. So, first and foremost, Lava is a blockchain that operates as a data access layer that gives any type of data consumer that needs access to blockchain data. It can be dApps, AI agents, wallets, indexers, and everything beyond that, access to decentralized RPC. And it enables those data consumers to access any type of blockchain out there and get the data that they need. I also would like to highlight the main reasons why Lava exists. So every type of interaction that happens on chain, it needs RPC, remote procedure call, right? Any type of interaction that we all do today, including making a trade, deploying a smart contract, claiming an airdrop, and anything in between, uses RPC as a standard protocol for reading data, writing data, and so on. So it's kind of like a fundamental piece of that infrastructure to access the data, read the data, and so on. And it's very important because every time there are some problems with the RPC infrastructure, it affects everything. Applications go down, users cannot get access to the data, they cannot do anything with the applications, and that costs a lot of money for the businesses and also really heavily affects the user experience. And there are some shortcomings with the current state of the infrastructure there, because the way it works right now is that when blockchains launch, most of the time when new developers try to build something on those new blockchains, they have to run their own node. And it's first of all costly to run the nodes, but also it can be quite complicated, right? There is quite a bit of a know-how that goes into knowing how to run the nodes, also how to update them, how to ensure that they operate at the highest standard. And as a result, a lot of developers resort to centralized RPC providers out there, which by definition creates the single point of failure. And it's complicated in a way that when there are some issues with centralized providers, then all of these developers and applications that use them, they are also heavily affected. The only alternative that is out there right now is that developers also can use public RPC and rely on community node runners to monitor and run those RPC nodes. But most of the time, public RPC comes with really restrictive rates for accessing the data that only really enables high-level prototyping or testing and not really active development. And most of the blockchain projects don't really have any mechanisms to incentivize those community node runners to ensure that the nodes that they are running, that they meet the highest standard when it comes to data availability, the uptime, and things like that. And quite often, community nodes, unfortunately, are down, and it's difficult to rely on them for building production-grade applications. So this is why Lava exists, and this is the problem that Lava is really trying to tackle, which is to provide developers with reliable RPC infrastructure that just works, and developers can actually focus on building rather than running their own nodes or relying on other solutions that also intrinsically create potential problems later down the line. So just very quickly, I have a very, very simplified overview of what happens under the hood. And it would be, I think, important for people to understand the core mechanism of Lava, because then you will understand what Lava brings to the table when it comes to infrastructure. Again, this is very simplified, but hopefully that will make it easier to understand. So on one side, we have users. It can be wallets, dApps, AI agents, and they need data to build their applications. And when they use Lava RPC, they have a bunch of different interfaces that they can use. One of them is Public RPC, which is something that Lava collaborates on with different blockchain projects. And Arbitrum is actually one of those projects that Lava is collaborating with to provide Arbitrum developers with public, completely free, and very reliable, high uptime, and fast RPC to build applications. There are other interfaces as well. There is Lava Gateway that developers can use, and it allows developers to upgrade their access rates and scale their applications as they go. There are enterprise offerings like Smart Router as well. But the most important thing here is that those interfaces pass the incoming RPC traffic, all of those requests, and send them to the Lava pairing mechanism. And Lava pairing mechanism is that important engine that routes the traffic to the best, most optimal, and best performing RPC provider. And there is an entire network of RPC providers that service every single chain that is supported on Lava. RPC providers can join Lava completely permissionlessly. Ben, you and I, we can be Lava RPC providers any day. And those providers are also monitored, and the pairing mechanism looks at the historical performance of a provider, and also they look at details like providers' availability, sync, latency, and things like that. Also, they look into that trustworthiness of a provider, which is expressed in a stake, because every single provider, they have to stake some Lava to join the network. But all of these details are taken into consideration when deciding which provider will serve the incoming traffic. And also because it's a decentralized network, and there is a network of providers that are servicing each chain. If one provider has an issue, if they go down, another provider takes over seamlessly, and the end user doesn't really see any difference. There are two key things that I think ensures that Lava provides on the promise that the RPC that Lava provides is very reliable and extremely high uptime, is because, first of all, the decentralized nature of the network creates this playing field for all of the RPC providers, which means that they kind of have to compete with other providers that are joining the network and servicing the requests for the chains, for example, Arbitrum. And the way they compete is through their quality of service. So the best one wins. So providers always strive for better results. And then also, chains that Lava collaborates with, for example, Arbitrum, they can sponsor pools, which are rewards that are then distributed to providers for the work that they do, once again, based on the quality that they provided with their RPC nodes. So it's like that mechanism that incentivizes the providers to really strive for the best. And as a result, again, the users on the other side, they get reliable RPC, they get public RPC, and they can just go ahead and build. So those are the key things that I wanted everyone to understand about what Lava is, how does it work, and yeah, I hope that this is just gives you a little bit better picture of that.
That was really a fantastic introduction. And I think one of the things that stood out for me as you were talking was really two things. One was the decentralized nature of Lava's network and how it really just fits into the ethos of what we're trying to build in blockchain in general. And supporting that is this idea that when we're building, one of the things we sometimes forget about is the infrastructure and how integral the infrastructure is. And we want to have the best code we can have, most optimal optimal code formatting and syntax and code comments, and make sure everything is like, time, space, complexity, perfect. But sometimes we forget that the core infrastructure is so integral to the overall performance of our applications. And if we can achieve that along with the decentralized nature, really in line with and aligned with the spirit of what we're trying to build in this space, that just seems like to me like a major win. So I really appreciate personally that introduction. I think everyone who's watching this is also going to really appreciate that introduction. And along the same lines of thinking about infrastructure and how it improves developer experience, we have to spend just at least a minute talking about what is Stylus. Because if you look at Arbitrum and you think about what Arbitrum offers, one word that's going to pop up for you quite a lot, and you're going to see this word all the time, is the word stylus. Well, stylus is itself not a programming language. It's not a domain-specific language at DSL. Stylus is actually a virtual machine. It's a VM. And it lives co-equally next to the Ethereum virtual machine, to the EVM. So instead of trying to offer an alternative VM to compete with the EVM, we're not doing that. What we're saying instead is we want to live in a world that is fully aligned with Ethereum. We roll up to Ethereum, we support Ethereum, we inherit the security of Ethereum, and we want to also offer maybe a more modern, more performance-enhanced developer environment to launch your projects and build your smart contracts that share the exact same state tree as the EVM. So that's what Stylus is. Stylus is a WebAssembly VM that lives alongside the EVM. And it gives you the ability, for example, to write smart contracts in any language that compiles to WebAssembly into WASM. Now, most famously, that means Rust. And we all talk about that. And we have in the Arbitrum community officially supported a very, very good, robust Rust SDK for Stylus. But it also means, Justina, and many people don't realize this, it means C. And it means C++, and it means Golang. And even recently, another member of our ecosystem community has started putting out an alpha version of a TypeScript SDK that gets compiled to AssemblyScript, which is a variant of TypeScript, and then into WebAssembly, into WASM. So you can start writing your smart contracts in all of these languages. And what do they all have in common? Well, maybe not TypeScript as much, but that may just be my bias. But all of them have in common that they are incredibly battle-tested and enterprise-level languages. So we're not writing little games anymore, and nothing wrong with games, but we're writing the financial rails of the future of the world. And those financial rails, the future of the world, should be written in languages that are enterprise level supported, that have tens and tens of millions of developers contributing to those languages and using those languages, not just in Web3, but in TradFi, in security, in e-commerce, in all sorts of industries. So we get to inherit the benefits when we write in C or C++ or in Rust. We get to inherit the benefits of those large, huge developer ecosystems and use all those tools. And it also allows us to be able to bring in developers who would otherwise maybe be a bit turned off by having to learn a more niche narrow language like Solidity. And there's nothing wrong with Solidity. We all love Solidity. We use it a lot, but it is constrained and it is narrow and it does have issues. It was created in a certain time, in a certain era of like certain bit machines and certain memory constraints, and we can benefit from the utilization of languages that are maybe a bit more robust, that have some like benefits like just-in-time, better performance benefits, near native, almost like kernel level speed performance, optimizations around security, by default type safety, all sorts of things. So Stylus gives all of those benefits along with being fully compatible with the Ethereum virtual machine with EVM. But what does that mean in practice? Just to give one small example, let's say you're writing a pretty robust application, Web3 application, and you have multiple contracts that you're writing. And one contract does one thing, another contract does another thing. Let's say you want to put some of your really intense computational stuff in a Stylus contract, in a Rust contract, maybe your cryptographic things, maybe some precompiles or something like that. You can call that Rust contract in your Solidity contract. You can benefit from using those Rust methods, your Stylus methods, inside your Solidity contract. And you can call your Solidity contract from inside your Stylus contract because they see each other. They share the same state tree. So we're not building a competing ecosystem. It's co-equal. It's the EVM plus. It's the multi-VM. It allows you to work inside Solidity, inside Rust, inside any language you want, and benefiting from all of the DevX and all the docs and all of the open source community and all of the industry standard enterprise battle tested languages out there to bring those into Web3, where right now, I would say we are precisely right now at the moment in time where we can benefit from that most, because Web3 is at a place where it is being embraced by the financial rails of the world. And so we're building the future of the financial world. We're building the next iteration of Robinhood. We're building the next iteration of PayPal. And those things, just as a small examples, need to be built with languages that can support the security guarantees that tens and tens and tens of millions of developers and end users rely upon. So that's just like a brief intro window into Stylus. And I think it is so amazing how Stylus and Lava can work together from an infrastructure level and from a developer experience level to really empower and accelerate smart contract development, new ideas, iteration, in a way that is fully aligned with the ethos of blockchain, in a way that's fully aligned with the spirit of decentralization and open source. So I'm actually really curious, Justina, do you happen to have for us a little demo that we can see that shows us what it may look like to run all these things together? Do you happen to have a demo like that?
In fact, I do.
That's amazing. What a coincidence. So
Exactly.
I would love to see this demo. Oh, wait, there it is. Who would have thought such a thing?
Magic. Yeah, so we have a very simple, it's extremely simple example of how we can build dApps using Arbitrum Stylus, use Lava RPC to run all of the transactions, get data, and so on. Really, the idea of this app example is just to showcase an example for you. It's not as much about the functionality and fancy features of the dApp, but it's really about things that are under the hood. So for this example, we have a simple dApp that interacts with an IRC20 token contract. I'm going to show you, we are going to deploy it using the Arbitrum Stylus SDK. And this dApp, it's very simple. It showcases the information about the token, which as you can see, very originally called token.
I love the originality. It's amazing.
And it allows you to mint new tokens, transfer them to an account, and you also get details about the transaction. So things like transaction hash, how much gas was used, and things like that. So this is where we pull the data from the blockchain to showcase that information. And yeah, all of this, once again, is done very quickly with Arbitrum Stylus to deploy the contract, and with Lava to power all of the interactions and all of the details that are needed to execute using the RPC. I will switch to my code right now, and I would like to show you how things work under the hood, and then we will come back and interact with this app a little bit.
Wait, so we're leaving the really fancy front end now. We're leaving the amazing front end UI. We're going to the code.
Exactly. Yes.
Oh, amazing. Okay.
So
I'm ready for that. I'm ready for it.
Let me just quickly share my screen again.
And I do think it's these kind of simple demos that really are really most demonstrative, because it strips away a lot of the complexity and just shows just at the very basic level what you can accomplish. And it's up to your imagination to understand, if I can accomplish this with these tooling, with these things? What can I accomplish at a larger level? So you're just showing the basic functionality in order to really show the ways in which they all kind of seamlessly integrate and work together.
Exactly. So can you see my screen? I'm showing the
Perfectly. I see VS Code.
Exactly. So let's have a look at a little bit of code. Again, it's going to be a bit higher level overview. So our app consists of just two key parts. One is the contracts, and another one is we have the front-end implementation of all of the features and everything that you just saw on the screen. So inside of the contract section, I do have the ERC20 token standard implementation. And as you can tell by the extension of the file, it is written in Rust, which again, I really like Arbitrum Stylus for the fact that it does allow developers to write smart contracts in languages that they prefer, the languages that they know. I think it's such a powerful thing to onboard new developers into Web3. So really big props to Arbitrum Stylus for that. And this contract implementation is something that maybe some of you also have seen in other places, because it's really just the ERC20 standard contract implementation. So what we have here is we define the parameters for the token that we will need to set, like the name, the symbol of the token. Then we define the storage layouts. And I think this is probably one of those really amazing things about Arbitrum Stylus, because it enables, for example, Rust developers here to define those storage layouts that map directly and mirror the storage layouts as if they were implemented in, if they were written in, let's say, Solidity. And this makes it very easy to migrate the contracts and also deploy them in all of these different languages. It creates the interoperability between the contracts and so on. So we define the balances, allowances, total supply. And then we have some of the definitions for the transfer, approval events, the errors that we might encounter. Then we have the methods that are necessary for the contract, some of them that aren't exposed to other contracts, like the transfer helper, mints, we have burns. So it's, again, the standard methods that we would have for the ERC20 token smart contract. And then we have some of the methods that are going to be public and available to other contracts, and we will be able to interact with some of these methods later on. So another thing that is here is the lib.rs. So it's like an entry point for the smart contract. And here we define the token parameters, the actual values. So again, my super original mind, I am setting them to my token name, and we just define the entry for the smart contract, and we basically are good to go ahead and deploy it.
So how do we deploy it, Justina?
It's very simple, and I'm going to show you in a second.
I've never seen this before working at Arbitrum. I'm so curious.
I have to preface, though, that of course I did quite a bit of the preparation for my development environment. So I do have Rust installed on my machine. I have Arbitrum Stylus installed and everything configured. But once you have everything configured, deploying a smart contract, I believe I might still have the command right here. If you can see on my terminal, I have a very simple command. It's cargo stylus deploy. And I will point to two important flags that we are including here. One of them is endpoint. So this is the first place where we do need to provide the RPC endpoint for the smart contract to be deployed. And as you can see, I am using the Arbitrum S, which means that we are going to deploy this contract to Arbitrum Sepolia. It's a testnet for us to run the application later on. And we have .lava.build, which means that I am using the public, completely free RPC endpoint that is provided by Lava and also provided by Arbitrum for the developers to go ahead and use. If any of the viewers will just get this URL, and if you plug it into your application, or if you follow along and maybe you will deploy your own smart contract as well, you will see that you don't even need to sign up anywhere to get this endpoint and use it. You just take it and build.
It really is. That really is a public good, like in the real fullness of the meaning. And you're using Cargo Stylus, which is, of course, the Stylus CLI that lets you deploy, lets you test. It also lets you check whether the contract can be deployed before deploying it, and really lets you interact with your contract from the command line.
Exactly. And the only other thing that I'm providing is the private key, which here corresponds to the private key of my wallet that I use for these kind of little applications and testing. It has some Arbitrum Sepolia testnet tokens there, so I can just go ahead and use it. Of course, always be very careful where you use private keys and never share them with anyone. This is
very important disclaimer.
And so to deploy the contract, I'm just gonna press enter, and after a few seconds, if everything goes well, we should deploy a fresh new contract for.
Which, by the way, one thing I want to call out for all the nerds here is that the latest release of the Stylus Rust SDK introduced constructor arguments as well. So now in version 0.9, if you're watching this, there may be a version 1.0 at some point soon, but from 0.9 onwards, you'll notice in Justina's terminal, it says checking whether the contract has a constructor. And what it's looking for is if you have a constructor with constructor arguments, you can actually pass those constructor arguments at deploy time and add them in at the same time that you're deploying. So along with that, and with trait-based inheritances, are a couple of the new features in the Rust Space SDK. Just a little shout out to some of the new features that are now available.
Amazing. Yeah, I'm probably one of the latest new users of Arbitrum Stylus because I looked into it fairly recently. But again, it's amazing how much easier and how simpler everything is when it comes to building applications, deploying
very much. So, and the constructor arguments is a nice, really, I've used it myself several times, a nice new enhancement to the developer experience.
Yeah, really happy about that, and definitely a great shout to developers to go ahead and try it out. So now we have the contract deployed. We have the contract address. We have the transaction hash. We can check it if we want, but I'm just going to go ahead and then show you a little bit of the front-end configuration, so you will see a little bit more where else we use Lava RPC, because we just deployed the contract using the public Lava RPC for Arbitrum Sepolia. And now if I just go into my React front end, and once again, I will just stick to the source directory, I have config file, and it's where I defined all of the important parameters that my dapp will need to know about and interact with. One of them is the contract address. So because we just deployed a new contract, I will change it to the new contract that we just deployed. We also include the network configuration, that is Arbitrum Sepolia indeed. And here again, I do specify that I am going to use the RPC URL, and that RPC URL is exactly the same that I used for deploying the contract, which is arbitrum s.lava.build. Once again, this is for the Arbitrum Sepolia public RPC endpoint provided by Lava. And inside of my app, maybe I have one of them open here. Exactly. So I am using ethers.js library here to initialize all of the interactions with the RPC. But what it does here is one of the examples. So if you remember when I showed the UI, and we will get back to the UI in a second, whenever I run, let's say when I mint tokens, I get the receipt of the transaction with the details about what happened, how much gas was used, and so on. So I have some of the methods here that are using Lava RPC to call methods like get transaction receipt and return the details about the transaction. And there are a few additional implementations. If I can quickly find. So we have a few more receipts. So this is where the configuration of the Lava RPC happens, so that it's then being used across the application. But we also have another one. Okay, this is what I was looking for. The little app, and I will show you that in a second, it also returns the details about the Lava RPC status. So every 5 seconds, it fetches the details about the Lava network, the block number, gas price, and things like that. This is just to showcase that, of course, applications, they sometimes are a bit more data intensive. And of course, when you build your apps and you have hopefully millions and maybe hundreds of millions of users using your dapps, the scale gets much bigger. And that need for reliable data and RPC providers becomes very, very important. So this is just to showcase a little bit more active interaction with the dapp. And again, what happens here is that we have the Lava RPC endpoint configured that we did in the config file. And then the app calls the methods like get network, get block number, get gas price, the usual traditional ones, and then displays that information on the screen. I'm going to launch the application just to go back to it and showcase once again the functionality. So I'll just quickly switch the directories. Okay, I think we are where we should be.
Yep.
All right, so this just restarts everything because, again, remember, we launched the new contract. So we are going to just restart the application as well. So I'm going to connect with my MetaMask. And yeah, so once again, we can mint the new tokens here as well, because I'm using my MetaMask to approve the transactions. I also configured my MetaMask to use public RPC for Arbitrum Sepolia. So here as well, we are using the Lava RPC to mint the tokens. And yeah, so I minted 5 tokens.
Of my token, very originally named, but yes.
We have the transaction receipt. So if you remember, Lava RPC was used to fetch the details about the transaction hash, block, and everything else. And this little checker on Lava network is here. So every 5 seconds, you see that these numbers here, like the block hash, they change. And under the hood as well, we simply use Lava RPC to fetch those details from the network and display them here. Again, this is just to showcase how easy it is to get going. Like, you have Arbitrum Stylus that makes it easy for you to write contracts in all of these different programming languages that you feel more comfortable with than maybe Solidity, or maybe you don't want to use Solidity. And then deploying the contracts, as you also seen, it's simple, some simple commands. And then you need RPC to power all of the interactions and transactions and everything else. You have Lava Public RPC for Arbitrum. So I just really hope that those tools will make it easier for developers to just get going and focus on building rather than thinking about the infrastructure that they can use to achieve those things and build great dApps.
Well, that was really an awesome demo. I think I learned personally a lot, and I can imagine everyone's going to be watching this is going to be learning a lot. And again, like you really took was a pretty straightforward example and walked us through the back end, both the contract level and on the front end level, and showed us in the implementation in the browser. And really, just like what I was struck with, honestly, was how seamless it was. Like it was just really, it was very minor. The change was very small, both in the deployment in the from the CLI command to what you had to do in the actual front end with working with Ethers.js, and then how it just worked. And honestly, one of the things that I think we could all benefit from more is just things just working. Like they just work. And to know that you're using something that's coming from a decentralized place that's aligned with the values, that is a public good supported by Lava and Arbitrum, and that is also benefiting, and you can do it in the sense benefiting from the developer experience and the versatility of language support of Stylus living alongside the EVM, I think is just a win-win on basically every level. So I really appreciate this walkthrough. I think it's going to be incredibly beneficial for everyone. And I'm actually like super curious now to know, like, what if I wanted to do follow-up? How do I learn more? Where do I go? What do I do? Justina, educate us more. Where do we go from here?
Yeah, so the best place to learn more about Lava is, of course, our documentation. So if you head to docs.lavanet.xyz, yeah, so I have the Lava documentation up here. So it's docs.lavanet.xyz, and you will find all of the information about Lava, the protocol, how to become Lava RPC provider if you would like to, how to access Lava RPC and everything else. And then, of course, another great place to keep up with everything that is happening is to follow Lava on Twitter. Just look for LavaNet and you will find us there. Join Discord, join Telegram groups that you will see. You will find all of the links on the Lava website and Lava documentation as well. And I am there always to help out all of the developers who need any kind of help and would like to know more about Lava. So definitely, please reach out to me.
Thank you so much. And those are fantastic resources. And really just, I'm excited to see, I know you're excited to see also what people start building and what they continue to build, utilizing the resources of Lava, paired with the power, the speed, performance, and the level of support that Arbitrum offers developers as well. So thank you very much for your time, and super excited to stay in touch with all of the folks and all the builders that are watching this and what you are going to build. We just would love to see. So be in touch with us and keep on building.